Welcome to today's episode, where we're diving into the fascinating world of automating research and development. With us is Dr. Emily Carter, an expert in AI and R&D processes. Emily, thanks for joining us.
It's great to be here. I'm excited to talk about how AI is transforming the R&D landscape.
Let's start with the basics. How can automating R&D processes benefit researchers?
Automating R&D can really lighten the load for researchers. Imagine you're a scientist trying to test hundreds of hypotheses. Traditionally, you'd manually conduct each experiment, which is time-consuming and exhausting. Automation can handle repetitive tasks, freeing researchers to focus on creative problem-solving and innovation.
That sounds like a game changer. How do large language models like GPT-4 fit into this picture?
GPT-4 and similar models are incredibly versatile. They can perform tasks like extracting information from vast datasets and implementing research methods. For example, if you're working on a new drug, GPT-4 could sift through medical journals to find relevant studies, summarize them, and even suggest experimental methods.
But there must be challenges, right? What are the main hurdles?
Absolutely, there are challenges. The sheer complexity and volume of experiments in R&D can overwhelm current AI models. They often struggle with understanding and executing complex tasks accurately. It's like asking a novice chef to prepare a gourmet meal without a detailed recipe.
So, how do we overcome these challenges?
One promising approach is developing benchmarks like RD2Bench. These benchmarks help evaluate how well models perform in automating R&D tasks, especially complex ones. By understanding their strengths and weaknesses, we can guide future improvements.
Can you give us an example of how these benchmarks work?
Sure. RD2Bench might test a model's ability to extract data from a complex scientific paper and apply it to a new experiment. If the model struggles, researchers can tweak its training to improve performance. It's like refining a musician's skills by focusing on challenging pieces.
And what about improving the models themselves?
Enhancing the pre-training and capacity of foundation models is crucial. This means feeding them more diverse and complex data during training. Think of it as giving a student a broader curriculum to prepare them for advanced topics.
What are the broader implications of automating R&D?
The potential is enormous. Automation could revolutionize productivity by allowing researchers to focus on innovation rather than routine tasks. It could also democratize R&D, making high-level research accessible to smaller institutions or individual researchers who might not have the resources for extensive experimentation.
That's fascinating. Could you explain the concept of data-centric automatic R&D, or DCARD?
DCARD is a framework for using data-driven models to automate research processes. It's about leveraging data to drive every aspect of R&D, from hypothesis generation to method implementation. Imagine a smart assistant that not only finds relevant data but also suggests how to use it effectively.
It sounds like we're on the brink of a new era in research. What does the future hold for AI in R&D?
The future is bright. As we continue to improve LLM's understanding of domain-specific knowledge and complex data features, we'll see even more sophisticated applications. Continuous development and training will enable these models to handle increasingly complex tasks with greater stability.
Thank you, Emily, for sharing your insights. It's exciting to see how AI is shaping the future of research and development.
Thank you for having me. It's an exciting time for science and technology, and I'm thrilled to be part of the conversation.